Hello and welcome to a new video lecture. In today's lecture, I'm going to show you a few tips, techniques, and guidelines on how to become a professional data scientist. I will share with you my own experience and a few things that I have learned along the journey the hard way. I shall start by outlining the main bullet points. First, I will start by introducing the 70-20-10 learning model, and then I will share with you a few tips regarding how to organize your time and achieve a realistic timetable. And next, I will share with you tips and hints regarding finding a mentor to help you along the journey. I will be recommending a few textbooks that handle the topic. I will review the necessary programming languages and frameworks that are essential for this journey. And next, I will share a few online courses on Coursera and Udemy, which I have personally taken myself. I will also give you guidelines on how to select the projects you shall work on so that you can potentially increase the experience you gain in the field. We will discuss next the job finding techniques and methods, and I will be giving you a sneak preview on how to select the right hardware for the job. Then I will group together a few techniques that will help you maintain your performance on the long run. Finally, I will be sharing with you a coupon code for my Udemy course on Generative Adversarial Network and IoT. We shall start by discussing the 70-20-10 learning model. This learning model is based on assigning 70% of your time allocation to the formal training. And by formal training, it doesn't necessarily have to be a university or college diploma. It can be your own self-study. It can be off-campus bootcamp online course, as long as it has a structure and achieves the learning objectives at the end. So that's 70% of the learning process. 20% is allocated to the projects you are working on, the types of projects, the scale of projects, the people you work with on these projects as well. It adds to your own experience. And finally, 10% to other activities, attending conferences, watching online talks, attending meetups, reading blogs, and so on. So I believe in this learning model. I have first heard about the 70-20-10 learning model in a Coursera course on learning and development back in 2012, and ever since I have believed in it, and it has helped me a lot in my own personal experience. So whatever you are trying to learn, you will become better and you will master it by assigning the right proportions to the right categories. So if you unbalance this learning process, you will not achieve the results that you hope for. For example, if you only attend meetups on the topic, but you don't have any structured learning method, or you don't have hands-on projects experience, then you are not going to achieve anything, or you will achieve very little compared to what you will achieve in terms of mastery of the field when you follow these guidelines. It is very important to highlight this percentage and allocations in the beginning because it will help you to focus your energy and will help you organize your time better when it comes to achieving the mastery in data science or any other field if you are interested. So the take home from this slide is to wisely assign your time to the three categories and plan them very well in order to achieve the desired objectives. And don't waste your time, energy, and resources on unnecessary activities that doesn't build up your own profile. So it's time to talk about how to design your timetable, how to allocate the time according to the previous guidelines in the 70-20-10 model. You start by asking yourself this question: how many hours can you assign per week to studying data science? Let's say, for example, that you have a full-time job and you don't have the flexibility or the luxury of working on this plan full-time with complete concentration and dedication. It's still possible to achieve measurable results if you start by allocating some hours to this new project in your life or this life-changing project and create some barriers between your full-time job and this endeavor. Be aware when designing your timetable that you have to maintain a steady pace. That is, if you allocate 12 hours per week, then you have to allocate 12 hours per week every week for the next year. It doesn't do much good when you work 1 week 40 hours and then you don't work on this endeavor for the next coming 3 weeks, for example. So 12 hours per week for every week along the next year, that's 52 weeks almost. So that will help you to achieve better results because the learning process itself is a slow and a steady process. Your brain will stretch like muscles you are training in the gymnasium. So your brain will better absorb the new information, skills, and knowledge by having it done step by step in a steady pace. One of the major issues that I find when when anybody starts a new journey is that he is very optimistic and very energetic about it, very excited to get started. He starts with a very high pace, like 40, 50 or even 60 hours per week, and then slowly decays and his passion fades away, and this is not really good at all. Also, some people will start with a very high energy, very high level of motivation, and then they will have unrealistic timetable. For example, they are doing a 40-hour full-time job per week and they still assign to this endeavor 20 or 30 hours, which is not feasible, and you will burn out very soon on the short run. So if you are in this game for the long run, you have to be realistic about how many hours you can allocate to this project every week. Also be aware that if you can allocate 12 hours and you are not leaving any tolerance or room for error, let's say for example you are not assigning time to spend with your family, friends, even travel or just rest at home, you need to assign this time very wisely, again, because if you don't be realistic about this time allocation, you will not be able to stand up to it and achieve the desired result. So if you have 12 hours per week that you can spare, I will be more likely to say that these are actually 8 hours, because I will leave out 4 hours for other social activities and relaxation so that you can maintain your energy and focus on the long run. The next item in today's list is a mentor. It's very important to have a human instructor in the process. Even though the technology, mobile applications, and the platforms like Coursera and others help you achieve your learning goals, but still, a human in the loop is very important for the reasons that I will explain in deeper detail as follows. Having a human element in the process, such as the mentor or instructor, will help you to stay motivated. Let's say that this week you have allocated 8 hours, the next week you allocate only 7 hours, and you have not achieved your weekly goals. Having weekly catch-ups and status updates with your instructor will help you stay motivated, because you will always feel proud of yourself when you present your weekly work and efforts to your instructor and engage with him in a rich and fruitful discussion that will help you even further and nurture your knowledge. A human instructor will also help you stay on track. Let's say, for example, that you're studying data science for self-driving cars or for any other specialization, and then you get drifted away by a new, amazing, exciting topic. Let's say, for example, drug discovery. And it is exciting, it's new, it's novel, but it really isn't the goal that you have set in your learning goals before you started this journey. Having the instructor with a good experience will be able to tell you whether engaging that much in such a side topic will distract you from your main goal or will help you achieve your main goal. So this is a very important point, because most of the time technology is very fast, new papers are coming out on daily basis, and there are many challenges and many exciting areas in the field that will distract you from your main goal. A good instructor with decent level of experience will also give you useful consultations on the topics that you are studying, on the papers that you are reading, on the books that you are consulting on daily basis, and will also help you with recommendations on the projects you are working on, how to level up the difficulty of the ideas, and also will give you consultation if some ideas are beyond your level at a certain point. So this kind of consultations on both the topics and the projects will help you not only stay on track but achieve your learning goal, and will prevent you from giving up too early, because if some topic is challenging, such as data science profession in general, so you will be more likely to get discouraged and give up very early. But a good instructor will help you navigate and explore this very rough area. Last to mention on this item, it is not always easy to find a good instructor with the right experience and the right level of commitment, but you can try to find a good instructor in your local community, university campus, even online. There are many platforms that have right talents with decent level of experience that offer such consultations for an hourly compensation. As for myself, when I try to learn any new topic, I will start by finding the right set of books. Not just one book. I will have a set of different books on the same topic to view the topic from different perspectives and also at different levels, because when you are starting with a new topic, you need an introductory textbook that will explore all the available branches and subfields in this topic. And then as you become more experienced in the topic, you will need a more focused, advanced book that will handle more advanced and hidden secret and tips. And as you become more experienced in the topic, you will need more advanced, concentrated, focused or specialized books that will attend to more difficult or challenging areas in this topic. On this slide, I will be sharing with you a few recommendations. They are not the only recommendations on the topic, but these are the books that I have personally read in my journey to become a data scientist. And also I believe this set of books is good to have for any professional data scientist. Be aware, by recommending these books to you, I'm not subscribed to any sponsorship or business affiliation. I'm just recommending my own personal experience and the books that I have personally read in my journey. The first book is Neural Networks and Learning Machines by Simon Hyken, and it is a generic book on the topic of neural networks. It discusses the origins of neural networks, the mathematical foundations and the mathematical derivations of neural networks, and gives you a good foundation in the topic by starting with Rosenblatt perceptron and then scales up to multi-layer perceptron, and even discusses topics like SOMs, self-organizing maps. The good thing about this book is that it has a very solid, comprehensive mathematical derivation for every topic that it discusses, and I find the mathematical foundations to be equally important to coding and building these models using a computer program, because it gives you the common sense of the field in general. The next book on this list is Deep Learning by Ian Goodfellow and Yoshua Bengio, and this book is an open source book on the MIT website. You can download it as a PDF. As for myself, I don't really prefer PDFs because you can easily navigate the PDF on the computer, but myself, I prefer the old school learning with a paper and pencil so that I can take notes and highlight important points, and also gives me a sense of achievement when I complete a chapter and when I arrive at a certain milestone in my reading, and I can reference it easily, have it always on my desk, and read it or when I'm traveling. So I always prefer the paper and pencil approach because it's more interacting and more engaging other than the PDF. I'm not saying that the PDF is useless. It is very important as well. One must benefit from the technology in different ways. I will use the PDF for quickly skimming over a topic or finding something really quickly or referencing something in my writings and so on. But still, my favorite approach to learning or reading a book is the paper and pencil approach or the paperback. The good thing about this book is that it gives you a very wide landscape view of the topic. It starts with basics in algebra, probability and statistics, and starts with a refresher on machine learning techniques, and then it dedicates the rest of the book to the innovations in deep learning, convolution network, recurrent neural networks, generative adversarial networks, autoencoders, and kind of very comprehensive, gives you the bird eye view that you need as a beginner to get your introduction to the topic. It has a decent level of mathematical involvement, and it doesn't seem to assume an advanced background in mathematics or the required probability and statistics for deep learning. It has a lot of explanations, graphs, and I believe it is a kind of the book on the topic. The next book is Pattern Classification by Richard Duda, and this is kind of the book that gives you a comprehensive guidelines on classic machine learning techniques, everything that is preceding to deep learning, and it gives you the mathematical foundation and rigorous mathematical derivations for every model and every techniques, and many variations for the same technique, and includes a very rich set of models and techniques in classic machine learning. You will also find the book Deep Learning with Python by Francois Collet, very interesting, very engaging. very easy to read and understand. And what makes it stand out from the other books that I've mentioned so far is that it does not dive very deep into the mathematics, but it gives you analogies, it gives you illustrative examples from your daily life on how these models work, tries to simulate the mechanics and the physics of the model with graphs and diagrams that will make your life easier and gives you the intuition of the models and their inner workings. Besides, and it is using Python, so it is very easy to follow, and I would recommend this book to the beginners who would like to get engaged quickly with real projects and start coding early on. Besides, one of the main advantages is that most of the data science professionals now are using Python, and this book will get you acquainted with the different methods and techniques, coding paradigms available in Python, along with how to implement deep learning with these programming tools. Last on this list of recommendations is The Digital Image Processing by Rafael C. Gonzalez, and this book is for those who are interested more in computer vision and image processing. It gives you the complete foundations in image processing or digital image processing, how to process images, how to represent images in the computer, how to do the contour finding techniques, segmentation, and all of the classic techniques that will enable you to perform handy jobs and real projects with images even before starting to use deep learning or machine learning at all. And let's not forget that even though deep learning and machine learning are way more advanced than classic digital image processing techniques, but still some basic tasks will require knowledge of how to convert an image from RGB to grayscale, how to find the contours, how to do some corrections on the image, and so on. And sometimes, when solving a problem in real-life projects, I find it easier to solve with digital image processing techniques such as histogram matching or watersheding algorithm for segmentation and so on, because when you process the image with these techniques, which are very well established techniques with analytical derivations, it is less demanding in terms of computing requirements compared to deep learning. I would say that one must have a good exposure to these techniques before deciding to use a more modern complex technique, because in many cases I have seen people using deep learning for very simple tasks that can be achieved using a classic technique, but they are missing out on this because they have jumped right into the modern technique without first mastering the basics. And remember, deep learning itself requires extensive use of GPUs and a lot of mathematical operations in the process, so always consult the classic techniques that were proven and worked before jumping right into the more advanced tool. I can't say that this list is comprehensive by any means. These are only the books that I find essential to get you started and that I have read personally and helped me in my own journey as well. As you progress more in your journey, you will discover more books and publications that will address your interesting topics that you're excited about. As a programmer myself, I never had any difficulty with programming. I have been doing that for many years now, and I have graduated from computer science department, so that was the core of my curriculum, programming in many different types and techniques and paradigms. However, the challenge for data science is that it's multidisciplinary, and it is not only for programmers, but you'll find in many cases mathematicians, graduates of the science department, and other disciplines working in the field, but they kind of miss on the fact that a decent level of knowledge in programming is really an essential qualification. So one never invests enough time in learning the programming techniques itself, and they just skim through the basics and they struggle later on as the techniques they are trying to apply or implement become more advanced, and also they kind of miss out on the performance overhead of the implementations they are using. So a decent level of programming is really essential, and I can't stress that enough. Allocate enough time, as much as you can, to learning and mastering programming. And in the following list, I will list the basic programming languages that are essential for the data science career. The first on my list, which doesn't mean the highest priority, is the R language, and I find it very interesting because you can't only do statistics and probability solutions with R language, but you can also integrate with Apache Spark for big data applications. You can integrate with TensorFlow or Keras, and you can do deep learning. It has a very powerful integrated development environment, IDE, which is RStudio, and it has all the tools that you need, from plotting graphs, printing diagrams, working with different data sets, and it will strengthen your skills and knowledge, especially in the area of statistics, because even the blogs and the forums for R language, they are written by statisticians, mathematicians, who are more oriented to the mathematical part of the process. And it doesn't stop there. You can even build very nice and neat graphical user interfaces or web applications using the Shiny extension of the R language. Just remember, it is not the only way or the only right way to do web applications using R language, because when it comes to production and deployment, there are many considerations for performance and scalability that are better addressed in other languages. And it is kind of goes without saying the Python language, which is now the de facto programming language for data science, and all the major frameworks for deep learning and machine learning, they are in Python. You can use scikit-learn, PyTorch, TensorFlow, and a few other libraries. They are all written in Python, and it's kind of a must-have skill for any data scientist. Having said that, R and Python are not the only way to do data science. You can also use Julia programming language, which is relatively newer programming language and oriented for machine learning and deep learning. And as for myself, I am more oriented towards the back-end development of data science or of machine learning models. So I will be using Java and Scala. I'll be using Apache Spark, Hadoop, and so on for doing analytics at a larger scale. But still, if you are beginning into the field, I would say R and Python are the starting steps for you, and you can't go without having a decent level of knowledge in these two programming languages. Over time, TensorFlow has become very important and very essential for any data scientist, and it is a must-have tool, and it has provided many extensions like TensorFlow JS for JavaScript building client-side applications in the browser, and you can use TensorFlow Lite for mobile applications or even embedded systems on Raspberry Pi or NVIDIA Jetson Nano. I would like to highlight that TensorFlow is not written in Python. It is a declarative programming language, and it has a wrapper in Python so that you can write your own code in Python and communicate with TensorFlow underlying infrastructure. I would also like to highlight that TensorFlow 2 is fundamentally very different from TensorFlow 1 in the patterns introduced, the libraries, the extensions, and there are a lot of pre-built and trained models in TensorFlow Hub that you can make use of in your development. On the other hand, an equally good framework for deep learning is PyTorch, and it has a lot of extensions as well, and a lot of libraries in the ecosystem around it, and a very well written documentation, tutorials, and even my own course on Udemy is written in PyTorch. I would always prefer PyTorch when it comes to prototyping and experimenting because it's very clean, very easy, very well organized, and the PyTorch open source community maintain a very well backward compatibility ethics, and this helps because it doesn't often break your old code when they update the code base. Again, as the case with the text box that I have recommended, this list of programming languages and frameworks are not the only way or the only thing that is required. It is just the basics, and as I've told you myself, I'm doing more Java than I'm doing Python. And based on the projects that you will be engaged with and the scale of these projects, that will determine the libraries, the tools, and the ecosystem you will be working with. So now I'll share with you a few online courses, which again I have personally completed online and helped me throughout my journey. Be aware that there is no sponsorship or business affiliation with these recommendations. It is completely based on a personal experience. It goes without saying the Coursera course on machine learning by Andrew Ng was and still the holy grail of this field. Almost every data scientist professional have completed this course or attempted to at some point. This course does a very good job in explaining the basics of machine learning, the different models, support vector machines, logistic regression, linear regression, and many others like decision trees, random forest, and so on. The only thing about this course is that it was first written in MATLAB. The only downside of this course is that the coding exercises are in MATLAB, which is not very handy because everybody now is using either R or Python, and MATLAB itself, and as far as I'm concerned, MATLAB is only for educational purpose, and even if you try to deploy MATLAB models to production, it is not as easy, requires licensing and MATLAB infrastructure or servers, and it is not as smooth or as familiar when it comes to Python and R. Again, it is a very good foundational course that you can't miss out. The next online course is a set of courses actually. It is the Deep Learning Specialization, again by Andrew NG, and it is accessible on Coursera and on deeplearning.ai. You can also find many parts of these courses available on YouTube. You can watch for free, organized by the topics as you search and filter. Again, on YouTube, there is the Stanford course CS 231 or 231, and this course is very comprehensive. It covers many of the techniques of modern deep learning, especially for computer vision. It is a very well structured course, very entertaining, very intellectually amusing, and the good thing about this course I like the most is that for every topic it covers, it doesn't only cover the basics or the mathematics of the topic, but also it brings in publications and research papers in chronological order or in some interesting order that address the same topics. So as far as I'm concerned, it is more research oriented to help you get on your feet when navigating the research papers published on the deep learning topic, especially in the area of convolutional neural networks, but it also covers recurrent neural networks at some points to handle natural language processing. The next course on my list today is on Udemy by Frank Kane. Personally, I find this course very amusing, very easy, very illustrative. It uses very simple language, it doesn't use technical jargon, and it covers a wide range of topics. The good thing is that it's all in Python, a lot of hands-on exercise that you can code along, and as a beginner, this course will help you get on your feet very quickly and jump right into the coding with good exercises and examples. Finally, I would recommend you to have a look at the complete guide to TensorFlow for deep learning with Python by Jose Portilla. And this course was written in TensorFlow version 1. I haven't really checked whether they have updated it to version 2, but it is worth mentioning this title and recommending it to you. Just don't forget to check whether it's still using TensorFlow 1 or it has updated the content to TensorFlow 2 as well. So this list of online courses is not the only list that I would recommend. There are many other courses, equally good courses, but these again are the things that I have personally tried myself in my own journey. So now we come to a very important point. What kind of projects I should work on as a beginner and as I develop throughout the process? Usually this is the case that you start with a simple project like working with handwritten digits dataset, MNIST, and then you think you have become a data scientist. You do something that is conventional and easy to do and has been done in every tutorial on every online blog on the topic, and then when you start working in real life projects, it is never the same thing, and you don't really have the required qualifications to work on a real project. So in this slide, I'll try to break it down so that you can have at least some guidelines on the kind of projects you work on at any different stage of your journey. First of all, I don't like people to start working with fancy projects or infeasible projects that require a team of researchers to solve the problem. Always start with something simple, and achievable, and follow the structured approach either by benchmarking a textbook or an online course or any one of the things that we have mentioned so far. What's really important is that you don't keep on doing the simple project for your entire career. Otherwise, you will end up not having a career at all. So I would recommend, after spending 2 months or 3 months, based on the pace that you have set or the time allocated to this endeavor, then you start to level up the difficulty of the projects you are working on. I cannot stress it enough why it is important to pick a specialization. First of all, there are many subtopics in deep learning. There are many problems that you can address with the deep learning or machine learning in general. And once you start working with one specialization, I find it much better to stay focused on this area other than spreading yourself very thin on other topics and still doing the hello world or MNIST kind of sample projects in each area of them. There are many new techniques, there are many challenges that haven't been solved yet. So you will always find a problem to solve, a project to work on. Just remember, you have to stay focused. Next, I will give you example of specializations just to whet your appetite, but that's of course not every single specialization in the topic, just some of the interesting ones that you can consider in your learning plan. You can focus your energy, efforts and studying on natural language processing, machine translation, question answering. There are many similar topics in the area of natural language processing that are very challenging, very interesting, and you can address one of them. Or you can choose the area of drug discovery, which requires knowledge of pharmaceuticals, biology, and on the area of deep learning, it requires knowledge of deep reinforcement learning, graph networks, and generative adversarial networks as well. Some will find the area of fraud detection in financial transactions very interesting, and indeed it is. There are many startups every day on TechCrunch that are specialized in addressing this problem, especially that there are billions of financial transactions online every second. One of the very interesting specializations is recommendations engines for e-commerce. For example, when you visit Amazon.com, you have people who also bought these items, or this item goes well with these other items. These kind of recommendations are very important business-wise because they make a huge difference in the turnover or return on investment in e-commerce processes. And not only in e-commerce, even on Netflix, when you are watching a movie, you get recommendations for similar movies or recommendations based on how similar your profile is to other users who have watched the same movies that you have watched so far. I would like to add that recommender systems are very high in demand in the job market, besides being a very interesting topic as well. With the revolution in automated vehicles, electric cars or clean cars, companies like Tesla, everybody is seeking self-driving cars. And as you know, the conventional automotive industry has been a real driver in the economy, and huge economies of large countries are established on the automotive industry itself. So if you are interested in the self-driving specialization, you will acquire knowledge in reinforcement learning and computer vision, and you will find it very exciting and very rewarding in the job market as well. One of the underrated areas in deep learning is mixed reality. By mixed reality, I mean augmented reality or virtual reality. And myself, I've worked on a couple of projects in this area. It's very challenging. There are many techniques from computer graphics, deep learning, computer vision that you can apply in this field. Also, it requires a lot of optimization because most of the applications of mixed reality are required to be operating with a decent level of hardware requirements on mobile applications or even Oculus devices. This list should give you an idea of the specializations available in deep learning, but it's not everything as usual. It is just to whet your appetite, and the take home from this slide is that you start with simple projects and gradually increase the difficulty of the projects you are working on. Of course, as I have mentioned before, you need an instructor or a mentor or a structured textbook to help you navigate this process as well. And once you are confident with the basics, then you start to directing your efforts and time allocations towards a specialization so that you can take the most out of this journey. And also this will help you land a good job with higher probability than others who are just mastering the basics or doing hello world or MNIST examples in each field without really mastering one specialization of deep learning. It remains to mention that if you are specialized in one area, it doesn't mean that you completely forget about the others, because the deep learning topics are interrelated, and sometimes you can borrow ideas from one discipline and apply it in your own area or to your own problem in your own new project. This is quite often the case. So for example, you can apply generative adversarial networks in drug discovery to find out the valid combinations of molecules, and you can apply generative adversarial networks in self-driving cars to synthesize images from the readings of the sensors. So you will find these interchangeably plug-and-play components of deep learning applicable between these specializations. I would say apply here the 80-20 rule. The 80-20 rule is that you will assign 80% of your effort and time to your specialization and 20% to other topics that are interesting, exciting, and up to date in other areas, so that you have the good of both worlds. So don't mix it up with the 70-20-10 rule. So now you have been working according to the plan for 3 or 6 months. It's time to find a job. Be careful at this point, because in the job market, there are many candidates who claim to know deep learning or data science, but they don't really have the required skills. Again, as I've mentioned, they have only been doing the projects in blogs or Hello World style projects, or only working with the basics, which is very unrelated or irrelevant to the requirements of the job. For example, it is not very uncommon to find a candidate applying for a job in fraud detection who has never done any projects on fraud detection, but has only been working with the basics and Hello World level style of projects. The point I'm trying to make here is that you should not rush yourself into claiming to have acquired the necessary skills and qualifications to find a job. Take your time. Learning is a slow process. You learn incrementally and slowly every day, but on a steady pace. Also, don't commit to a job that you cannot deliver to the end. It is very often that someone will start a project and then find out in the middle that he doesn't have the required skills to carry it to the end, because it's far too complicated, or because the techniques have not matured yet to handle this problem, or many other reasons that will make it infeasible to complete the job. This will hurt your career badly. Don't do that. Take your time, learn well, study slowly, and only start applying for jobs when you are ready. As a fresh graduate without much experience in the field, it's hard to land a job just out after college, so you may start with freelancing smaller projects or parts of projects to people in your network, or even on online platforms if applicable. If you don't have the required experience, you can start by applying for internships at companies that have projects related to your area of specialization. Make sure to choose the company wisely, because the internships that you do along the way will determine what kind of engineer you become once you have completed and acquired the experience. For example, if you start in e-commerce or recommender systems, then you will be more qualified to have this kind of projects all along than to jump to self-driving cars or drug discovery or any other specialization which you haven't built the profile for it yet. Once you have become confident in your skills and qualifications, then you can start applying for jobs at good companies that you dream to work with in your area of specialization. Don't give up too soon. Apply as much as possible. Try to find contacts who work in these companies. Reach out to them, try to get some recommendations, and if you have been doing it all right so far with the structured approach I have described, I believe you will have a very high probability of landing your dream job. The next couple of items are not really related to job finding, but it is more like a habit that every data scientist develops along the way. The first is Kaggle competitions. Kaggle is a very rich platform where you can find experience of other data scientists. You can find notebooks, examples, discussions, and even competitions that you can participate in for a rewarding prize and the right level of exposure to the recruiters from big companies like Google and Facebook. If you are more like an entrepreneur, then I believe you will find working on personal projects more interesting, and it is very exciting to build something on the side, and once it is mature, you can bring it to the world and help change the lives of people. Applying these new wonderful technologies help them achieve things like finding the cheapest pizza online and even addressing more challenging problems such as climate change, natural disasters, and famine. One of the questions that every data scientist has: what kind of hardware do I need to get started? Do I need a fancy hardware to get started, expensive hardware, or how should I go about the hardware budget? When it comes to the tools that you're working with, whether you have a PC, standard PC, personal computer, or a laptop, I would personally prefer the personal computer. First of all, it is cheaper than a laptop, And second, you can get higher specifications with the same budget in terms of memory, CPU, and GPU performance. And personally, I put together my own personal computer with the specifications and parts that I choose myself, and sometimes you will find the laptop more convenient because it's portable. However, it doesn't give you the same performance as a personal computer unless you have a higher budget. The question is whether you really need to build a GPU rack with such high specifications in order to get started. The answer is no. You don't need a fancy hardware to get started. You can always use cloud GPUs such as Google Colab, Kaggle, or even purchase hourly recyclable preempted clusters on Amazon or Google Cloud, which are cheaper than the standard cluster because it does not guarantee to complete the job. It can be preempted at any point of time because you are actually leasing or renting the idle time of other renters or other tenants on the cloud. This or that, the point is you don't really need an on-premise dedicated high-spec hardware because you can always use cloud solutions, either free or paid. But let's assume that you have got the budget to get a graphic processing unit or GPU. What kind of GPU could you get and what to watch out for when purchasing a GPU? For absolute beginners, I would say GTX 1050 or GTX 1080 is a good choice, a right balance between budget and specs. And if you're a fan of using a laptop over a personal computer, you can still wire it externally as in the image on the screen using a connector which has its own dedicated power supply and connect it on the USB port of the laptop. If you have your own personal computer, you wouldn't need this dedicated external setup, but if you have a laptop and you want to use your GPU and do your deep learning training on the laptop, you can try this wiring scheme and you can still enjoy the benefits of both worlds by having the portability and the high spec. I would like to highlight one important point about the GPUs. When purchasing a GPU, be aware that the GPU memory matters. If you have a choice between a GPU with 2 gigs of memory or another one with 11 gigs of memory, go for the higher number of memory because the higher the memory, the more it can handle larger epochs, larger batch size, higher resolution images, and you can do more with the memory. But if you end up with the 1 gigs of memory, then you will still be very limited in what you can do. Be aware that the setup I am previewing here is for beginners. If you want to consult other references for how to build a dedicated deep learning machine, I would recommend you to consult the Kaggle Grandmaster blogs because they share tips and tricks of how they build their own computers for Kaggle competitions. So far we have kind of covered many tips and tricks on how to become a professional data scientist. We have almost covered the main points in the 70-20-10 model. The following slide will cover the remaining 10%, which is more about attending to talks, reading blogs, or subscribing to newsletters, even having discussions online or offline with peers, colleagues, and masters in the field, and most importantly, reading new publications on the topics that you're interested in. There are new publications on daily basis. You should have a weekly reading routine when you constantly download and read the new papers to stay on the top of the updates in the field. Again, you can apply the 80-20 rule by having 80% of the time dedicated to whatever project you are working on or the job that you have landed, and 20% of the time assigned to these extracurricular activities. So far I have shared with you my own recipe for becoming a professional data scientist. I hope it helps you in your own journey to land your dream job. Finally, at the end of this lecture, I would like to share with you a coupon code to my Udemy course on generative adversarial networks and another course on IoT development using Arduino Uno and C++. You will find the link to the course in the description and the coupon code again in the description. Here is the coupon code YouTube-channel, and you can use this coupon code on the following courses on Udemy: Introduction to Generative Adversarial Networks with PyTorch, or the other course, Beginning Arduino Uno Programming in C++. You can use it with one of them or both of them. Thank you and see you in a future lecture.